हेलो स्टूडेंट, यहाँ पे क्वेश्चन है that a particle of mass m is allowed to oscillate near the point of minima of a vertical parabolic path having the equation x square equals to 4ay, where x-axis is along the horizontal direction and y-axis is along the vertical direction. The angular frequency of small oscillations of the particle is. So look here, we have to draw a diagram, a parabola whose equation is x square equal to 4y ay. That means कि this is an upward parabola. Means if this is x-axis and this one is y-axis, then our parabola is upward like this. This is the equation for x square equals to 4ay. Now a particle is oscillating about the minima. Means this is the minimum point, and about this point a particle is oscillating like this. Okay, so it is oscillating like this. So suppose the particle is at this position, initial means at any instant the particle is at this position. So we have to calculate the angular frequency of small oscillations. Okay, so what is angular frequency? So omega is angular frequency, and we will use the equation a equal to minus omega square x. This is an equation for SHM where a is acceleration towards the mean position, omega is angular frequency, x is displacement. Now suppose if the particle is at this position, then what are the forces that acts on this particle? A weight of the particle is acting downward and its component along the mean position, means this is the mean position. So along this position will be, if this angle is theta, okay, with x-axis, then this will be 90 minus theta and it becomes theta. So it is mg cos theta and this one is mg sin theta. So mg sin theta is a force which tries to bring the particle to back to its minimum position, means equilibrium position. So the force, restoring force, is equal to minus mg sin theta. Minus indicates the direction of restoring force towards the mean position. From equation of SHM we have studied F equals to minus kx, where F is restoring force. Okay. Now if F restoring is equal to minus of mg sin theta, and from Newton's laws of motion, force is mass into acceleration, which is equals to minus of mg sin theta. So m is cancelled out. A becomes equals to minus of g sin theta. And if the theta is very small, theta is the angle with x-axis for this tangent. So if theta is small, then we know that ki sin theta is also nearly equal to tan theta. So we will replace here sin theta as minus of g tan theta. Means acceleration becomes equals to minus of g tan theta. And from where we will find the value of tan theta? So from the equation of the parabola, which is x square equal to 4ay. So if we will differentiate it with respect to x, means 2x equals to 4a dy upon dx. So this is dy upon dx, this is the slope, and we know that slope is tan theta. Slope dy by dx equal to tan theta. So in place of tan theta, we will write the value of dy upon dx. So dy upon dx becomes equals to x upon 2a. So we are putting the value of tan theta, a equals to minus of g x upon 2a. So it is in the form of g upon 2a into x. And if we will compare this equation with a equal to minus omega square x, then we get the angular frequency omega square equals to g upon 2a. That means ki omega is equal to root under g upon 2a. I hope you understood this question. Thank you so much for watching.